Mr. Uday Ningawale.
Sir, he will, ma'am, Akshita will give an introduction first, and then you can
Okay.
start. Okay.
Yes. Good morning, one and all present here. On the behalf of Biomedical Engineering Department of Vidyanagar Institute of Technology, I, Akshita Suresh, welcomes you all for the second event of Impulse 2022. The subject of today's event is continuous renal replacement therapy, that is CRRT. The speaker for this event is Mr. Uday Ningawale. His expertise is in designing and planning dialysis units and is currently operating education services and clinical management at Renal Consulting Services Private Limited. He has a lot of expertise as a senior technician from Kokla Dhirubhai Ambani Hospital and Jaslok Hospital and Research Center. Before I go ahead, here are a few instructions to all of our participants. Requesting you all to note down all your queries in the chat section, and we will be addressing them all at the end of the session. I would like to request you all to fill the feedback form at the end in the order to avail the certificate. The link for all of the above will be provided in the chat section. Now, without any further delay, I would like to call upon today's speaker, Mr. Uday Ningawale, and ask him to continue the event. Thank you, sir. You can continue.
Good morning, everybody. Today our topic is going to discuss on the CRRT. So outline of this, my topic actually, what is the meaning of the CRRT? Then why the renal replacement is needed in the healthcare? Why continuous renal replacement has to be there, and comparison between the regular hemodialysis and CRRT. Why choose the CRRT? Because there is some of the criteria has been chosen for the CRRT, whether it can be used for the hemodialysis, the patient can be get tolerated very well, then there is no need of the CRRT. But when we have to choose the CRRT, and what are the indications for the choosing this CRRT therapy in the healthcare? And above that, there is a CRRT basic components. We are going to discuss about this basic components needed for the CRRT, then system overview and basic alarm overview, and how we have to work on the ending the treatments. So I'm going to cover up these topics in this session. As you are aware that actually CRRT, that means the abbreviation of is continuous renal replacement therapy. As you know, in our the organ, the kidney works 24/7. So it is working in our body is continuously, and that's why to substitute the kidney functions, the CRRT stands. There are various of the dialysis is available, which is hemodialysis, peritoneal dialysis, and CRRT. And after that, there is renal transplant. So it is the one type of the verge of the hemodialysis, the continuous therapy. It is to be maintain the kidney functions continuously. The CRRT stands for. And as you know, it is a slow continuous renal replacement therapy, and definition of it, any extracorporeal blood purification therapy intend to substitute for impaired renal functions. Some of the patients having the renal function is impaired, it get just substitute by this therapy over an extended period of the time and applied for the aim to at being applied for 24 hours a day. Generally, when we start this therapy in the intensive care, actually the minimum duration of this time is 24 hours, and it can be extended to the 72 hours or furthermore also, depends on the condition of the patient. Now the question comes, why renal replacement needed? So when the kidney get impaired, non-functioning, the waste products is get accumulated in the body, that is the solutes. Acid-base balance, thus acidosis has been increased, the pH level is decline as acid concentration is increasing. Then electrolytes get imbalance and fluid get accumulated in the body. To get correction of this all things, that work by the kidney. Kidney is not work, so that's why it has to be needs to be replaced by this replacement, the artificially verge of the dialysis therapy. So in the dialysis therapy, we can remove these solutes with the help of the diffusion concept. The solute is actually solute also with the diffusion concept, and fluid can be removed with the ultrafiltration or convection concept. So mainly when you see that there is a two type dialysis, that is the hemodialysis and CRRT. Hemodialysis is mainly focused on the solute clearance, mainly on the diffusive clearance. And in CRRT, it is mainly focused on the convective clearance. There is a in the hemodialysis, water is removed with the help of the ultrafiltration, whereas in the CRRT, additional to the ultrafiltration, the convective clearance is also takes place. So where the middle molecules can be taken out very easily with the help of the convective clearance. Now there are modality available is 4 hours of the dialysis treatments twice a week, thrice a week available. But in these cases, the patients, why we need the continuous renal replacement. So removal of the waste product, as you see in the previous slide, additional to that, renal recovery needed. Once the kidney gate fail, if you that load has been taken by this one of the mode of the dialysis therapy, the kidney get chance to recover it, and there is a chances of the recovery around 90% in the acute stage of the kidney failure. If there is a chronic kidney failure, there is the reversibility is very less. But in acute therapy, renal recovery is possible with the prompt treatment of the kidney as a dialysis. Also, hemodynamically, it has to be safe and prevent further kidney damage. The hemodynamic safe with the help of this. When you see the compare with the hemodialysis, there's a limitations to perform the hemodialysis. If the blood pressure of the patients with the supportive is above 100 up to 90, we can continue the hemodialysis procedure. But when the blood pressure of the patient is fall below that level, below 90, 80, 70, the treatment is only available is a continuous renal replacement therapy. So when you see that this therapy is very advanced therapy, when the all other therapies are not going to be work out, that time the high-end therapy is a continuous renal replacement therapy. And it will be also, when you do it continuously, it will prevent the further damage to the kidney, because all the kidney functions, whatever the which is a major one, is been taken care by this CRRT. So kidney get relaxed and it can be get reverse. So comparison between the hemodialysis and CRRT, the chart you can see when the kidney is not functioning, the mainly you can find out the blood urea nitrogen and creatinine level is get elevated. We can see about this in the this graph. The BUN has been shown. It will be in the range of the 60 to 100 in the pre-dialysis. So red line shows when you before the starting the hemodialysis, the BUN is 100. After the over 4 hours of dialysis treatment, it brings down to the lower level, 60 or 40 or 20 also. And over a period of the 1 or 2 days of the gap, where dialysis treatment is not happening, it again go to the 100 and 120. But when you see the comparison of this CRRT, it will be continuous process. So it will be trying to maintain the level below the higher level. So that's why serum level of the uremic toxins will be abrupt changing in the hemodialysis scenario, and in the CRRT it is slowly but steadily decline. and that will be help to regain the kidney function in acute kidney failure. Why choose CRRT? CRRT closely mimics a native kidney. So as we say, as a native kidney functions 24/7, same way the CRRT functions 24 hours, 72 hours, or furthermore, as and when needed. So it is a slow and gentle continuous procedure. So there won't be any abrupt increasing in of the toxicity in the body. Once the toxicity is higher, slowly it will be read off with the help of this CRRT therapy, and well tolerated by hemodynamically unstable patients. Any cardiac issues are there, patients not able to having the very critical ill with multi-organ failures, various we can see in the further how it can be able to use, prevent further damage to the kidney tissues. So when you patient is put on the CRRT therapy, the further damage to the kidney can be get slower down, or it can be get prevented, promote healing and renal recovery. And with the help of this supportive therapy, the healing and recovery can possible. Also, with this, it regulates the electrolytes, acid-base balance. So electrolytes regulation takes place when there is a hyponatremia or hypernatremia. It can be get corrected. Acidosis is get corrected with the, because when you see this, actually a solution we are used is a bicarbonate base, is a buffer solution, and it will be correcting the blood pH, and then that's why the acid base balance is get corrected, removes large amount of fluid and waste products over time. So allow other supportive measures, that is a nutritional support, can be possible because needed. It is because it removes the large amount of the fluids as a waste products. So therapy, for the therapy indication, who is our patient, for the whom we can able to start this therapy, there is a criteria. As the indications for the CRRT in the ICU, it has to be performed only in the ICU setup, not in the OPD setup, not in the general ward. It has to be it can be possible, the therapy can be performed in the intensive care unit. And if there is a acidosis, that is AEIOU, acidosis, this is a metabolic acidosis due to the acid-base imbalance. This is example is a ARF. ARDS, that is acute respiratory destructive syndromes, or in patient is in sepsis. ARF is acute renal failure. Electrolyte imbalance, where it can be, this is the electrolyte imbalancing. Same, the ARF, ARDS, sepsis, and MOF, it is a multi-organ failure. When the various organs has get failed, the chances of the electrolyte imbalance. Intoxications, the water-soluble toxins, rhabdomyolysis, it is one of the type, and also because of the intoxications, medicine intoxications also. The patient went into the coma also, it can get recovered with the help of this hemoperfusion type of therapy. Then overloading, the fluid overload can be possible, that is, it can be happen because of the congestive heart failure, ARDS, and there is a BUNS. And uremia is only because of the acute renal failure. So these are the all type of the complications can need the therapy is a CRRT. So in the renal indications, the ARF with the oliguria meaning patient only pass about less than 400 ml of the urine over a 24 hours. Generally, it has to 1.5 and above, but hardly within the 24 hours it pass only the 400 ml of the urine. So the condition comes as a oliguria, and the renal functions is not properly deteriorating. Or anuria, there is no urine produced. In this case, azotemia, there is all medical condition happens because of the urea, creatinine, and various waste products in the blood has been increased. Volume overload, as urine is not produced, the volume is depletion takes place, volume accumulation takes place, and the fluid overload, volume overload has been happened, and tumorolysis syndrome, sepsis, and cerebral edema. Cerebral edema, there is a, can be happen in any of the cases as a oliguria or anuria is there and azotemia is there. Then non-renal indications. If the patient has drug overload, overdose, in these cases also the CRRT will be help out. Then metabolic disorders, that is the lactic acidosis. Mainly metabolic disorders is because of the lactic acidosis. This can be happen, and crush injury, that is rhabdomyolysis. It is actually the injury to the skeletal muscle or muscle cells, and it release into the circulation, resulting in the electrolyte imbalance, hypovolemia, metacidosis, coagulation therapy, and RF. And sepsis, ARDS is related to the lungs, actually acute respiratory destructive syndrome, and fluid overload is secondary to the congestive heart failure. So this is the some of the renal indications, some of the non-renal indications. So if you do this, actually it can be do with the two type of the renal supports and renal replacement. Life-threatening indications, that is hyperkalemia. When the potassium in the body, blood, is increased more than 6.5, it considered as a hyperkalemia, and it can be give the heart attack. It related to the heart attack, and it is a very life-threatening indications. Acidemia, pH is less than 7.1 due to the metabolic acidosis. Apart from that, there is a pulmonary edema. There is the water get accumulated in the body, and pulmonary edema is there. Definitely, patient saturation will be get dropped. It will be actually oxygen needed. Uremic complications, that is the pericarditis. If the pericardium, pericarditis, there is the heart outside. There is the pericardium, and it could enlarge the heart, and it when it pumping at time it pushes and rub, and there is a bleeding happens, that is called as pericarditis. And in that cases, the renal replacements is useful. Solute control, if solute control can be happen, fluid removal can possible, regulation of acid-base balance is possible with the renal replacement, and regulation of the electrolytes is possible. Where you think about the renal support, the nutritional supports, fluid removal in the congestive heart failure is possible. If there is in sepsis, the body releases cytokinin, and cytokinin can be going to be suppress the body, and it needs to be the manipulation is required in the sepsis conditions. Cancer chemotherapy drugs, because of that renal support required. Respiratory acidosis, that is in ARDS, and fluid management in the multi-organ failure. Fluid management in multi-organ failure also needed. These are the following proposed set to indicate which can be used as trigger for initiating CRRT. Non-obstructive oliguria, that is urine output less than 200 ml over 12 hours, or anuria. Severe acidemia, high lower the pH, that is metabolic acidosis. Azotemia, that urea more than the 30 millimoles per liter. Hyperkalemia above 6.5, potassium is more than 6.5 and rapidly rising. Suspecting uremic organ involvement, the pericarditis, encephalopathy, neuropathy, and myopathy. These are the actually other organs involvement in it can be caused need to be initiate the CRRT. Progressive and uncontrolled severe dysnatremia. There you can find out with this because of the multi-organ failure. Otherwise, acute renal failure, there will be the hypernatremia or maybe hyponatremia. The sodium level will be go D range, it is normally the 135 to 145 ml, but you will find out that dysnatremia, hypernatremia, or maybe hyponatremia. It needs to be corrected in the CRRT with the planning the proper electrolyte imbalance can be done. Uncontrolled hyperthermia, there will be the hyperthermia, clinically significant diuretics, unresponsive organ edema, especially lungs, drug overdose and dialysable toxins. Any of the drugs get overdose and dialysable toxins are there, it can be, by the CRRT, it can be taken care. Coagulopathy requiring the rapid administration of the large amount of blood products in the patients with the risk of pulmonary edema and ARDS. So there is a coagulopathy requiring coagulopathy requirement with the rapid administration of the large amount of blood. So if there is a bleeding is going on, the platelets has to be given, and some of the cases the hemoglobin is low, the blood transfusion has to be performed. So there is a possibility to perform the dialysis. So when you see, we can segregate some of the biochemical and clinical indications. Biochemical indications is hyperkalemia, serum urea, acidosis, electrolyte abnormalities. It may be natremia or calcemia, tumor syndrome with the hyperuricemia and hyperphosphatemia. Urea cycle defects the organic aciduria resulting in hyperammonemia or methylammonemia or acidemia. In these cases, this is the biochemical indications. Few of the clinical indications is definitely because of the urine production is low. When patient is because of the AKI, it goes into multi-organ failure, respiratory volume overload, end organ damage, that is pericarditis. So all this because of the heart or neurological disorders or uremic bleedings are there. Create intravascular space of the plasma and other products for infusion to nutrition, and severe poisoning or drug overdose. Severe poisoning cases also, this therapy can be used with another modality can be used. The role of CRRT in ARF is mainly to remove the toxin, that is urea creatine is a toxic substances accumulated into the blood, regulate electrolytes and water balance, regulate acid-base balance, prevent further damage to the kidney tissue, and promote healing of the recovery. So when you see of the congestive heart failure, how the CRRT will be held. It will maintain the 24/7 fluid balance. Any of the CRRT therapy, it will be maintain the 24/7 fluid balance. So reduce the ascites and peripheral edema, relieve pulmonary edema, which help to improve the heart functions. Normalize cardiac filling pressures. Maintain 24/7 electrolyte and acid-base balance. Dialytic control of the electrolytes and delivery of the bicarbonate lactate buffer or lactate buffer. Possibly prevent further renal damage or prolonged renal insufficiency. Possibly reduce length of stay. So definitely it will be useful in the congestive heart failure cases. Also, we can able to perform this while the patient having the renal problem, renal kidney problem, and he's undergoing the bypass surgery. During the bypass surgery also, in the bypass blood, we can able to merge this CRRT therapy, which is possible. What is the role of the CRRT in sepsis? If there is a patient is in septicemia, actually removal of middle and large molecule sepsis mediators by convection and adsorption, including TNF, alpha, IL-1, IL-6, and IL-8 through the CRRT. Removal of excess fluid and waste products. So when actually there is a sepsis, there is the body releases cytokines, the IL-1, IL-6, removal of excess fluid and waste products, maintain of acid-base balance, improve cardiovascular hemodynamic removal of the cardiodepressants that caused by inflammatory mediators, and thermoregulation. Thus, heat regulations of the body is possible because of the infections. Definitely there is so CRRT can be useful in rhabdomyolysis, maintain fluid electrolyte acid-base balance, prevent further damage to the kidney tissue. So when you, it can be removed up to the middle molecule proteins up to the 1700 Daltons through the convection method. May cause of the nonsense, blood leak detector alarm can be give the false alarm can be called. But when you see this, actually the fluid is coming from the drainage. You can see the bags. The first day it will be the very blood is immaturic fluid is coming. On the second day it come down, and on the third day it will get normal. So it will be there's a tissue damaging, slowly get improves, and then on the third day you will find out this. The role of the CRRT in intoxications. Any of the toxic drugs has been introduced in the body, the removal of the small molecules by dialysis. So regular dialysis, the small molecule substance can be removed. Dialysate up to the 4 liter per hour. Optional replacement up to the 500 ml per hour. And duration depends on the clearance of the toxic medications. If there's a toxic medications having, if it is not possible to come along with the dialysis, there is a hemoperfusion procedure is available, which can be performed on the CRRT machines. The various therapy also can be performed to take out the medicine overdose, such type of the treatments. This is about this clinical things, why needed the CRRT plays very important role in various type of the therapies, various type of the complications related to heart, related to multi-organ failure, it may relate to the acute renal failure or any of the tissue damage and getting the blood cells get damaged and getting the red blood cells coming into the actually uh, in the blood cells damaged tissues can be get taken care in the CRRT. Now, this is actually one of the CRRT machines. It's a Prismaplex manufactured by the Gambro, and now it is marketed by the Baxter India Limited. So we are going to discuss about the basic components of these machines. This is the CRRT machines. So for the CRRT performance, we require actually the CRRT system, that is machines. Then there is a CRRT kit, that is hemofilter. It is contains the semi-permeable membrane, that is hemofilter, and various tube pressure gauge are inbuilt into it. Also, they require this actually blood warmer. Blood warmer is required when you are giving the solutions. It needs to be go through the blood warmer to maintain the normal body temperature. When you perform this treatment in the ICU setup, the temperature is about 22 to 24 degree, and so there is hypothermia can be possible. So when you are giving these fluids to the patient body, the maintaining the normal body temperature needs to maintain, and which is possible only with the blood warmer. Then to perform this therapy, we require vascular acidosis. Vascular acidosis. Sorry, vascular access. As a double lumen, you can see this catheter, double lumen catheter. It may be double lumen or triple lumen, but we require one the vascular access to perform this therapy. One is actually, you can see this, there's a red clamp, which from there the blood is coming out into the system, and after this performing this purification of the blood, from the second line it will be returned into the body. That's why this vascular access needs to be created prior to start this therapy. In that there is a requirement of the anticoagulations. As you are aware, the blood is coming from this our body circuit. It will come in contact with the air, and it having a tendency to get clot. To avoid that clotting of the blood in the circuit, the anticoagulation needs to be infusion, continuous infusion needs to be there. And this is another solution which contains the bicarbonate and acid components. That it contains the sodium chloride, calcium chloride, magnesium chloride, and sodium bicarbonate, which sodium bicarbonate help as a buffer solution, and others will be maintaining the uh, electrolytes chemistry. So when you are thinking of the access, the veno-venous, double lumen or single lumen venous catheters has to be. So there are three locations where the internal jugular vein, it can be placed over here. Low risk and complication, simplicity of the catheter insertion. Femoral vein can be possible, and third one is a subclavian vein is possible. Those are three sites can be, but generally the internal jugular vein is very first priority has been given. It is very easily can be able to place by the intensivist in the ICU. Then femoral is very easy from the femoral vein. Subclavian is actually given high risk having the pneumothorax and hemothorax. So that's why it has to be given the least priority. Assess important in consideration. Refer to and follow the hospital protocol for the specific guidelines. Vascular access adequacy Loki guidelines recommended that aspirate and discard heparin before flushing. When that vascular access is filled with the diluted heparin, it has to be discard before the flush it before, and 20 to 30 ml syringe of the assess patency and check for the kinks and clamps. Anticoagulations mainly use is a heparin or another citrate remedies. Trisodium citrate can be used as a anticoagulations, but mainly the heparin is used as a anticoagulations. But in CRRT we can have the another options of the citrate anticoagulations. Purpose of warmers in CRRT: it will prevent heat loss, minimize calorie loss, and patient comfort can possible with the by using the heaters in the CRRT. Prismaflex disposable sets, pre-connected color code lines are there for easy to set load, color code labels for easy hemofilter set identifications. And there is a effluent bags in this box. You can see the effluent bags. It can be 5 liter to 9 liter effluent bags with the drain port of the quick emptying and a single priming effluent bag with the Y connectors. So very easy, and it is latex free. Disposable sets, single set for all therapy modality. Only one single kit is available. Multiple site of the replacement fluid infusion, then integrated pre-blood pump infusion for the access line for the flushing purpose. It can be PPP line can be used. High flow blood lines with the minimal pressure drops. Clear plastic pump covers. Easy visible and fluid pump segments also. And electrostatic discharge rings are also there to minimize the ECG artifacts. Integrated barcode reader. When you uploading the kit on the machine, there is integrated barcode readers. Once it read the barcode, it will be recognized and automatic alarm limits are get setting because there are various type of the kits are available. There's a just 30 kg per person, 50 kg, 60, 80 kg. The various kit is available. We can see this kits also. Pressure pots. There are no air interface for the minimized clotting. So there are pressure pots are also available. Then there is a pattern deaeration and monitoring system also available. If there is a air is there, the deaerations can be possible over. So unique deaeration chamber with a spinning cylinder. Button to top flow proper air bubbles upward to the automatic removal. Post replacement fluid layer elimination air and interface, return pressure monitoring, and small blood volumes about 8 ml. So if there's a, you can see this actually disposable sets, M60, M100, HF1000, and HF1400. That will depend on the various patient to patient body surface area. The selection can be taken. The commonly we are using this about the M100 is 0.9 square meter. It having primarily about the 1000 ml. There is a flow from 0 to 800 and 75 to 400, the blood flow rates, and blood volume about the 152 ml. So whatever the blood volume outside the patient body is about 152 ml in this circuits. Solution for CRRT. There's a solution required to perform the CRRT as a ready-made dialysis is available in the form of the bags. It can be used as a dialysis or as a replacement fluid. Both purpose can be solved with this solution. Depends on the mode of therapy, removal of the upward unwanted solutions, restore electrolyte and acid balance patient blood. Buffer, yeah, buffer solution, it is a sodium bicarbonate. It normalize the blood pH, balance ongoing endogenous acid productions, treat underlying metabolic acidosis, alkalosis, replace bicarbonate loss during the CRRT. So these are the actually indications for the using the solutions. So when you see the volume of the bag is a 5 liter ready to use solution. Only it can be divided into the A part and B part separated with the one of the. So when you are there's a one brake seal is there. Before the putting on the machine, it needs to be break and mix the both the solution prior to performing the treatment. Prior to performing the treatment, you have to mix A part and B part, the two separate parts with the frangible pin is red frangible pin breaking, and it has to be mixed and then it has to be put on the machine for the use, and it has to be mixed prior to use. Now coming to the actually continuous blood purification technology system overview. When you see the system, this display total machine has been divided into the three parts. That is the communication units. It gives the all alarm signaling, all the volume, what was the alarm pressures and all the thing. That is communication units. In between there is a flow control units. That various pumps are there. You can see the four pumps. There's a fifth pumps is also, that is blood pump. And down there is a weighing scales which can controls the fluid control units. So it having the three total system has been divided into three communication units, flow control units, and fluid control units. Communication units, interactive color touch screen, machine stated with the light it shows. Interactive display screen setup by setup instruction, total procedure, how to do load the set. Every instructions has been come on the display. The 12-inch color touch screen, display and color code diagram is required of the actions. And whatever you are perform, what is the status of the machines, give the general indication to operating conditions, that is green is normal treatment conditions. If yellow, advisory to the caution alarms, and red highest priority alarm condition needing the immediate interventions. Flow control units. Flow control units contains the blood and fluid pumps. There are you can see this four fluid pumps, and down there the white is actually blood pump. There is a syringe pump. For the heparin infusion, there is a syringe pump. On the right side of the machine, you can see pressure monitoring systems. You have the pinch valves, safety feature components, having along with the flow control units. So flow control unit, you can see the left side one, the effluent pump, right side, the green, it shows the dialysis pump. Below that, there is a replacement pump and pre-blood pump, PBP pump. And down with white, it is a blood pump. Left side, you can see the syringe where the anticoagulation as a heparin or any citrate infusion can be started. That is anticoagulation syringe pump. And there is a pinch valves to create the pressure and maintain the pressure within the limits. Flow control units, there is a return, effluent, pressure monitoring is also there. There are 4 types of the pressure: access pressure, filter pressure, effluent pressure, and return line pressure has been monitored during the treatments. Pressure monitoring. Pressure pod system is a diaphragm pressure pod, and it gives connected to the software. There's a blood lines coming through that, and it sends pressure sensors, and on that the machine will be display the pressure. Where pressure ports, return pressure ports, also the pressure ports is there. The monitored line is there, and below that there's the deaeration chambers. So whatever the air coming in the circuit before going to the patient, it has been always to be the air free. About this safety components, there is a blood leak detector sensor is there. Any effluent coming with the blood, it will work on the as like the optical blood leak detector is the photoelectric cells. It work on the photoelectric cells. Deaeration is work on the uh, deaeration chamber holder. There is air bubble detector, and there is a return line clamp is also there. There is barcode reader and ECG discharging is also present there. So this will give the safety precautions. Blood leak detectors, any blood leak happening, it will be detect immediately and give the alarm and stop the blood pump. If air in the circuit will get detected and it will stop the pump, and it will, in safety point of view of the patients, the corrective action has to be taken, and you can restart the pump. Flow control unit deaerating chamber allows semi-automatic air removal. Pour dilution fluid layer, approximately 200 ml per hour, eliminate air blood interface. So it will be continuously, whatever the air has been come in the circuit, it will get automatically released out and deaerating the chamber, and air free the blood is get supplied in the circuit. Flow rate summary. When there is a we can have the different type of modality of the CRRT. There is a SCUP, there is a CVVH, CVHD, and CVHDF. So SCUP is stand for slow continuous ultrafiltration. CVS continuous veno-venous hemofiltration. CVHD continuous veno-venous hemofiltration dialysis. CVHDF continuous veno-venous hemodialysis and filtration. So principle has been applied. For the performing the SCUP is ultrafiltration. For the CVH is the ultrafiltration and convections. And CVHD ultrafiltration diffusion. CVHDF ultrafiltration, diffusion, and convections. So always the better therapy is the CVHDF. So when you are performing, you have to select for the higher end therapy, and as per the patient need, you can from the CVHDF on during that therapy. Also, you can switch over on the CVH if you wanted to only perform the CVH or SCUP. But initially, you have to select the CVHDF therapy. Then you can work over there. CVHD, you wanted to change it out as per the patient need. You can switch over on the CVHD, CVH, SCUP also, and also upgrade. But initially, you have to select the CVHDF only. Then you can, in that range, you can switch over the modes also, and principles can be get uh, change over. Blood flow is actually maximum blood flow. It can be go. Patient fluid removal is a 2 liter per hour maximum. Dialysis in the CVSD and CVSDF. In the SCUP and CVSD, dialysis is not required. In CVSD and CVSDF, around 8 liter per hour maximum dialysis you can able to uh, give. Replacement is only needed in the CVH and CVHDF, and PPP, that pre pump, actually 1 liter per hour or 8 liter to 8 liter. Anything you can PPP line you can give that fluid. The total effluent volume is about 10 liter per hour. So fluid control. The third thing is the fluid control units. It having the various robust scales, very sensitive scales. It having the one is effluent, replacement fluid pump, scale, dialysis, secondary deployment, PPP pump. Scale hook assemblies, like the hooking assemblies are there. Color code tubing guided, which effluent will go, which scale that line has to be connected with the drainage bag. So this fluid control unit, scale hook assembly, slide out bar tray, removable carrying bar. The scales are the effluent, PVP, dialysate, and replacement fluid. So it will be measure, all these scales are measured, whatever the effluent has been come, whatever the PPP has been given, dialysate has been, it will get measured, whatever replacement has been given. This is about this overview. And now we are going see for this actually basic alarm overview. What type of the alarms come in the machines? About the basic overview. So safety features components is a alarm lights, indicates green, orange, or red. The alarm lights. Also display screen. There is a blood leak detector, pressure monitoring, barcode readers, syringe pump, air bubble detector, return line clamp, pressure monitors, and scales. So what are the safety features has been there? The alarm. The red indicates the warning and malfunction. There is a two category. It is divided into two categories. Patient hazards. The patient and system at risk needs immediate actions. Treatment is suspended during that period. Treatment is get suspended during the period because if we continue, it's going to be a risk to the system or patient. Malfunctioning, the failure to the of the safety system, patient and system at risk. These immediate actions, and during time the treatment gets suspended. In the orange indication, inform operator of an actions. Patient and system not at immediate risk. These actions, not an immediate risk, but if it get neglected, definitely there will be a problem to the system or maybe to the patients. These actions and treatment. In this condition, the treatment will be continue. Blood and syringe flow continue. So advisory, inform operators of an actions. Patient and system not at immediate risk. Treatment continues and blood pump and syringe flow continue. So these are the actually alarm indicators. With the indicators, we can find out what are the which is the priority and which is the highest priority and lower priority can be checked. But definitely in this therapy, immediately actions needed. The three troubleshooting commands, read screen. So when anything has been happen, you have to read the screen, follow the steps, and check manual, and follow the instruction. What is? So sometimes there is the alarm screens, warnings, give the Excess extremely negative, it gives a warning, and alarm is like that. You can see on the display. Everything is been shown. What is the action? What is the problem? Are there? What you have to do the actions and what are the possible costs has been given all details by the on the display by the machine. So the operator has to follow the instructions. Now alarm screen soft keys. The soft keys also available on the actually touch screen. There is the first switch is for the mute. Silence alarm beeps every 2 minutes. When you are correcting the problem, and then you can go for the, repeat the test for the alarm condition. Repeat the test for the alarm conditions. Override alarm for 60 seconds. You can bypass this alarm for the 60 seconds. Continue to clear the alarm and restart the pump. You can press the continue switch. Allow use to change set. If you wanted to change the set key totally, the new set you can go, and whatever the existing set will be come out. You have to just take out, disconnect it, and upload the new sets. This is the actually use when there is a clotting in the circuit takes place. You cannot able to use it further. So you have to be go for this new set and allow use to change set. So it will follow the instructions what is required to the taking out the set and applying the new sets. Open clamps, open return line clamp. There is a return line. If anything has been happen, alarm has come, it will be clamp the line. It will not allow anything go to the patient's body. So any of the actions you want to take it out and wanted to return the blood also, you can go for the open clamp. Examine alarms. These alarms allow user to view list of the active alarms. It will allow the user to view list of the active alarm. What type of the alarms are there? If you can see the number of multiple alarms are uh, there, you can see, and what are the alarm. You have to just correct it. It will get correcting it and resetting it. For the unloading set, just press the unload button. It will unload the set. Flow rates. You can go on with the switch and change the flow rates of the blood pumps, effluent pump, dialysis pump. Disconnect and change syringe. If you have the going for the changing the syringe has get empty, so you want to change the syringe, you go for the change syringe. The circuit will be continue, dialysis will continue, only the pump infusion will be get stop, and you can able to take out from the piston the syringe and upload the new syringe, and you can continue the syringe, and you can just start it. We are coming to the actually there is actually the monitoring the end treatment, how it possible, because anyone cannot able to do the ending the treatment. It has to be followed by the strict protocols what has been there. Then only you can able to properly terminate the system. If you just put blood pump switch off, it is going to be lock everything. That's why the end treatment also is important. So you have to have the stop key. Just stopping the pump may cause the clotting of the blood flow path. So resume the restart pump and resume the treatment. Otherwise, you can't change the set. You can go for the change set. You wanted to put in the recirculation, it will be circulate till that time. And ending the treatments, you can end the treatment. Then everything has been stopped. So when you put the stop button, resume, wanted to be continue, you can continue. Wanted to change set, Wanted to recirculations, wanted to be put into recirculations. Yes, you can disconnect the patient and we could put into recirculation. When you wanted to be stable, if one of the time patient get critical, resuscitation has been happen, that time we just disconnect the circuit, put into the recirculation and continue. After the patient settle, it can be reconnected it again. Otherwise, maximum blood can be put back and only the saline has been pushed and put into the recirculation. As when stabilize the patient, then again we can over a period of half an hour to 45 minutes also again we can reconnect the circuit. Once you go for the end treatment, you have to take it up and you cannot upload that set again. That's why, and that kit is very expensive. So that's why always you have to get what are the condition of the patients. Patient may get retrieve, then definitely there is a chance to be reconnected again over a period of the time. We can be go into the recirculations. If once you put the end treatment, you cannot go back. End treatments, then change set and recirculation. These are the three choice when you go for the ending the treatment. If you go for the end treatment, it's only the return blood. Cancel or reconnect. Once it will ask for the cancel it, you wanted to go back return blood, you can go for the return blood and disconnect it. It will go for the recirculate. Temporary disconnect require the blood return. Disconnect patient, circulate NS, that is normal saline. Reprime set before connecting the patients. Yes, it is possible with the recirculation. Blood pump is activated. Only immediate syringe is bolus if the syringe is active during the treatment. Volume of the normal saline recirculate adds to the total blood fluid process for the filter. Advisory alarm to change set occurs at 780 liter. So definitely this recirculate will be helped to save the kit for the restarting the patients when there is a requirement. Now ending the treatments. Ending treatment procedure, disconnect the patient. You have to disconnect the patient, unload or remove the filter sets and disconnect bags. Bags can has to disconnect. It is possible to end treatment with the without returning patient's blood. It's possible if it doesn't want to return blood, you can without returning the patient blood. Also, it's possible if there's a circuit is get clogged, you cannot be able to return the blood. So in this case, without return, or you can go with the disconnect. Continue. Disconnect the patient. Remaining solution can be used with a new set if desired. Perform steps below that. Clamp all lines in the set. Disconnect access the return line and disconnect the syringe from the syringe. Press unload to unload pump segment from the pump raceway. So warning will become unload, disable air bubble detected and other patient protection alarms. Ensure patient is disconnected before the pressing the unload. When you press the unload, it will be unload from the kit will be get unload and we have to just take it out and discard it. Confirm the unload. If you confirm the unload, then only the set is get unloading. Unload sequence may be result in patient injury if the patient is still connected. So access and return line must be disconnected from the patient properly clamped. And then you have to press the unload. And then there is a patient treatment get completed. Disconnect lines from the bags. Remove and discard the set and the bags. See, there is actually you will get the last treatment history about 90 hours are available. When you press the history, you will get the last 90 hours history treatment data is available. You can able to download it, download the treatment history data also. View or download. Turn off machine and treatment will be stored in the memory until the new next patient is procedure QR or press new treatment and to select the new procedure to load the new set. If you wanted to continue to go for the new set, you can go for the new treatment. So you can option is there. Otherwise, you can ending the treatments. So this is the precaution has to be has been taken, and it has been very well actually. Data is also be available in the history. So at the ending of the therapy, you can view the history or download the history also. So this is about the these presentations.
Okay, sir.
Yes, ma'am.
So we have questions in the chat section.
Yes, yes, yes.
Shall I begin?
Yes, ma'am.
Okay. So the first question is how to detect leak in the machine. So in the CRRT machine, if there is a leak, how is one able to detect that?
What is the question?
How to detect if there's a leak in the machine?
Leak in the machine. Hello. If there is any leakage in the system, the pressure will be machine will give the pressure alarms. The pressures are going to drop and machine will be not going to continue, and that is the indication there is a leakage in the machines because this machine doesn't having any hydraulic system.
Okay. All right, sir. So we'll go to the second question. Um, if CRRT is always considered for heart patient, won't it risk their overall health?
Yes. Actually, this therapy has come at the end. Various treatment therapy has been introduced to the patient if it is not able to tolerate and not able to. This is the end therapy. It is a expensive therapy.
Okay.
It is costing about 80 to 90,000 per day. The cost is coming for the treatment. And when there is a multi-organ failures, various heart cardiac issues are there, to support that therapy, this treatment is introduced and it will be help. But generally, when it is a wise decision, when before the time it has to be implemented. If the patient get deteriorate and delay in the treatment, patient recovery rate will be poor. So prior to if intensivist and nephrologist can be take call when to start this, but again there is the cost. General dialysis will be costing around 3 to 4,000, maximum 5,000 rupees, but this costing around 1 lakh rupees per day, and we don't know how many days it will be continue.
All right. All right. Okay. So it is usually preferable in the early stages of the disease if it is
That is a
UCI.
wide decision with the nephrologist and intensivist.
Okay. All right. Okay. The next question is how many days can we keep a person in CRRT?
That is depend on the of the patients. This machine is made for to run for the continuously. It can be run throughout that. There is a no limit. Only the kit get actually clotted over a period of 48 to 72 hours. So every third day, if you wanted to continue for the 20 days, 15 days, or every third day, you need to be change the kit and replace to the new. There is no limit to continue this.
Okay.
But
Okay.
as per the patient needs, it can be minimum it can be run for the 24 hours and maximum the one kit can be maximum for the 72 hours.
All right. All right. Okay. So the next question is, sir, can CRRT replace hemodialysis?
CRRT cannot replace the hemodialysis because the hemodialysis is only more focus in the uh, diffusive clearance, whereas CRRT is a convective clearance. Convective clearance, where the middle molecules taken care. In the
Okay.
hemodialysis, there is also again limitations of the what type of the filter we are using. If it is a low flux, middle flux, then we cannot take out the middle molecules.
All right.
And
Okay, sir. So the next question is, can this procedure be used for a healthy human once in a while to avoid further complications?
Uh, the dialysis therapy cannot use for the healthy wife. If there is a kidney impairment, then only it has to be applied. And this is the high-end therapy. When the patient is critical, in critical ill patient, can be put on the CRRT. Otherwise, before that, it will be managed with the hemodialysis.
Okay, 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 sir.
The availability of the machines also a challenge, and the cost also be challenged.
Okay, so is it such a that hemodialysis?
Healthy individual, we cannot able to, in a healthy individuals, we
Hmm.
cannot use the dialysis therapy.
Okay, okay. But sir, even if there is a kidney, sorry, a malfunction in the organ, is it that hemodialysis is first preferred and then CRRT is preferred? Is there anything like that?
That will depend on the actually what was the damage, whether patient critical conditions, what is his cardiac issues, whether he can his blood pressure, any supportive there. If there is a with the support, his blood pressure is 80, 90, we cannot able to start a hemodialysis. We have to
Okay,
go for the CRRT only.
okay, all right, okay. The next question is, sir, what if there is a malfunction in the ongoing process? What measures should we take, and what are the risks?
Yeah, ongoing procedure. See, machine is tested before the performing the treatment. All the parameters has been self-tested by the machines. If anything goes in between, we have to machine will be give the alarm. So we can have the safety precaution that alarm needs to be get corrected. And on during dialysis, if there is a any malfunction is happen, we have to safely terminate the procedure, keep the patient safe, and then again retest the machines. So it won't be if there is a possibility of the another machines is available with you, you can replace it. Otherwise, it can be just recalibrated. Only the problem is happening with the only for the scaling calibrations. They are very more sensitive.
Okay, okay, sir. So is it harmful if there's a failure and if we stop the process? So does it become like harmful or something?
It won't be because we are till that time we are given the procedure, and within half an hour we can able to retest it, and we can able resume the treatment also. Otherwise, not. There is another options. If his blood pressure is improves, and he can be put on the regular hemodialysis, like the slade and like the therapy can be possible.
Okay, sir. Okay. So the next question is, so this is not suggested for critical patients. So
It is suggested for the critical ill patient only.
yes, yes, yes. Okay, sir. So next question is CRRT very painful for patients?
Uh, it is not a painful for patient because it need of the patients.
Yeah. Okay. Okay. So
See, it is a acute renal failure. The jugular line has been put on the neck line, and it is connected. The blood has been taken out in the circuit for the procedure. But when you see the hemodialysis in the chronic renal failure, they have to the lifelong procedure. That is the lifelong procedure. It is short temporary procedure.
okay. Okay, sir. So the next question is, what is the difference between CRRT and plasma therapies?
The difference between the different actually there is a difference are there. CRRT is used for the continuous renal replacement therapy. When there is a renal replacement, renal impairment is there, the therapy is called as a CRRT. The
Okay.
plasmapheresis is not performed for the kidney failure. That
Okay.
is the other disease like the GBS syndrome, otherwise some of the neurological syndrome, anything of the uh, this protein, high protein things are there. Various disease, the therapy has been selected. And in that plasmapheresis, only the blood is coming brought out from outside the body, and it will get filtered through the plasma filter.
Okay, sir. Okay. Okay. So this is other question, that if the process is ongoing and there is a short circuit, or if the light goes off in between the process, so how what happens?
Machine having the power backup of
Oh,
the
all right.
20%.
Okay, 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 okay. So that is the end of the questionnaire. Um, is anyone having any other doubts? I'll wait for 5 to 10 seconds more.
Sir, this is actually a continuous process. Like it is not like dialysis where we will be sent for dialysis for some days and then we can take a break. It is not like that. It is a continuous. You
It
are
is continuous
like ICU.
process. It is continuous process, ma'am. It will
Okay.
be minimum run for the 24 hours, and it is only for the it is performed in the intensive care unit, critically ill
Okay.
patient.
Okay. Like ventilator, when you are on ventilator, the
Yes,
same
patient on
way
the
CRR.
ventilator. Yeah,
Okay. So for any particular operation or surgery, you may require it. Is it like that? If you are
yeah.
doing the
Yes, yes.
transplant, sort of
Some of the
kidney
times
transplant.
transplant it doesn't require, but
Okay.
some of the times this therapy is required when the patient having the cardiac surgery and
Okay.
patient having the renal impairment during the surgery also.
Okay. Okay.
There are various type of the therapies also available. Hemoperfusion we can perform in the bypass blood also. But
Okay.
CRRT also, if there is a known case of the chronic renal failure and his kidneys, he's on dialysis. If his bypass is going on, if anything needed in between also in the bypass blood, we can merge this therapy also. Also, this can be used, this CRRT there's a with this CRRT machine, there is a advanced therapies, various advanced therapies also can be planned. You must be knowing about the ECMO, that is heart lung machine, the in ARDS.
Yeah. Yeah.
With the ECMO therapy is going on, in that also we can merge this CRRT therapy.
Okay. Okay. But
Also, there is along with this machine, there is another Mars therapy, molecular reabsorption circulation system. It is done for the liver dialysis. That is one of the type of the liver dialysis.
oh.
So various filters has been merged into that. Around four filters are there. Actually, it is a combination of the plasmapheresis, CRRT, dialysis, and hemoperfusion combination.
Okay.
So there is a plasma is get filtered from the blood. That plasma is passed through this CRRT machine for this hemofilter. From that, it will go for the adsorption column, that is the charcoal filter. From that, it will go pass through the cation and anion exchanger, and then that plasma will be go again into the blood. That is called as the Mars therapy.
Okay. Great. Sir, then in the kidney transplant and all, when they are removing, so what they are doing, like a heart lung machine, they do for open heart surgery. The same way for kidney transplant, they do no, what they do normally.
In kidney transplant, actually they take out the organ from the donor,
Yeah, yeah.
and recipient kidneys, whatever the his native kidneys are kept same. Below that, they implant the third kidney.
Okay. So they don't remove the original kidney.
Original kidney can be removed prior to the surgery if there is a kidney having some of the complications, problem, infections. Then the
Okay.
nephrectomy can be taken done, and then the transplant can be done prior to that. But generally, if the kidneys are a little bit give the 8 to 10% functions, so they keep the native kidneys and add the third kidney in the kidney transplant.
Okay. Okay. So there is a space for keeping the new kidney in the body.
Yes,
We,
there is actually below that both the kidneys there is they have the space, and mainly urologists do perform this transplants.
okay. Okay. There are many more, some more questions. Akshita, you please go through.
Yes, ma'am. So another question is, can this therapy be given to complete renal failure patients? If yes, though is it is much more better than regular hemodialysis process, won't it be costing more than the regular procedure because the patient is needed to be in ICU for this?
Yeah, when the patient is in ICU in critical conditions, the CRRT therapy is given to stabilize the patients. Once stabilize the patients, he will be come out from the ICU and it can be turned back in his hemodialysis treatment.
Okay, sir, but if it is a complete renal failure, then?
See, the hemodialysis is going given for the treatment for the complete renal failure patients only.
Okay, 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 okay. All right, sir. All right. Um, yes, sir. So, is there anybody else who would like to ask a question? Okay, so there's a question. So, is it that CRRT and ECMO can be used at the same time?
Yes, if the patient with the ARDS, the acute respiratory distress syndrome, the ECMO is going on, and in that he developed the kidney failure symptoms, the fluid overload and anything, then the CRRT can be merged into the ECMO.
Okay. All right. Okay, sir. Is there any other questions, or if anyone has any questions, they can raise their hands and we'll be giving access to your mics as well. Is there any other questions? Okay, so there's another question. Does like some standby machines in the OT, can this machine be also be kept as a standby, that is in case of emergencies?
See, actually, this machine is very expensive and keeping as a standby. In the OT, it can be movable, it is on wheels. It can be go to the bedside. So it cannot be keep as a standby in the OT because if anybody needed a CRRT, it has to be given to them. When you're doing the surgery, we don't know whether after the surgery also you may require. So in the ICU it can be available, but it can be performed at as and where if there is OT required, the machine can be shipped over there. But the you will find out in Mumbai also big hospital having the one single CRT or two CRT machines.
Okay. Okay.
The requirement is very poor. Need is a very poor and acceptance means the cost is also very high. That's why the patient's acceptance is also poor. So very few people will be preferred for the CRT.
Okay, so can you give us an approximate idea of how costly CRRT costs for?
CRT machine costly about the 15 lakhs, where the hemodialysis machine costing about the 7 lakhs. And
Okay.
this what are the filter we are using for the dialysis is about the 1,000 to 200 rupees. But this kit is costing about 18,000 rupees.
Okay.
Oh, and for this actually hemodialysis, we can prepare the dialysis, which costing very less because with the help of the RO water, the dialysis can be prepared. Where it has been having the Prismapur solution, the one bag costing around 3,500 rupees, and it may be per day. It may be required 25 to 30 bags. The cost you can calculate that. Around 50 to 60, 70,000, the cost is coming of this. Then the procedures charges, doctor charges, hospital charges, and that's why it is going coming around 1 lakh rupees per day cost. Where the hemodialysis is costing around 3,000 rupees per day.
Okay, okay, okay. That is a very vast difference. Also, sir, how many hospitals in Mumbai provide CRRT procedures?
Many of the corporate hospital having the CRRT machines.
Okay, okay,
Also, the government hospitals also having the CRRT machines. I
okay,
will name like the KEM Hospital, Nair Hospital, then Seven Hill Hospital also having the CRRT machines. And most of the corporate hospital having the CRRT machines. It
okay.
will name around 20 machines will be available in the Mumbai.
Oh, all right. Okay, 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 sir. We'll wait just 2 more minutes if there is any other questions, and then we can wind up, sir. Any other questions? Anyone who wants to ask and interact with sir can also raise their hands, and we'll give you all access to your mics. Is there any other questions? Okay. Ritija, you can go forward.
Hello, sir.
Yes.
So, as an hemodialysis machine, there is some fixed ratio of bicarbonate acid and RO. So,
Yes.
is it similar in CRRT machine?
Ma'am, actually, in the machine, hemodialysis machine, the dilution ratio of the A part, B part, and RO water is 8.3 as to 34 part of the RO water. It has been, the machine will be prepared the dialysate. Whereas in this machine, the ready-made dialysate is available in the form of the ready-made packed bag, that is sterile bags.
Okay, sir. Thank you.
Yeah, it will be go with the flow. In the hemodialysis machine, it will be minimum go as a 30 liter per hour, where can be in this machine it can be go to 2 liter per hour. Otherwise, maximum it can be go to the 8 liter per hour. So more the diffusive clearance will be the less, and more is the convective clearance is take place in the CRRT.
Thank you, sir. Akshita, you can take over.
Is there anyone else who would like to ask a question? Ma'am, sir, is anyone else who would like to ask sir a question? Or otherwise we can end. Ma'am, shall we?
Okay, we can continue. We can end.
Okay.
Thank you.
Uh, Yes, today my words are not enough to express my gratitude. Thank you so much, sir, for taking out your precious time and sharing your precious knowledge with all of us and helping us to learn a little more about this vast topic. Thank you all for the faculty members and the participants for being a part and making this interactive event a great success. Team Impulse would like to request all the participants to fill the feedback form. Thank you, everyone. Thank you, sir. Thank you, ma'am. Thank you, and stay safe.
One picture we have to take by switching on the camera. One session picture.
Yes, definitely. Can I request Team Impulse to please switch on the camera and the
All
professor?
participants also to switch on the camera. Whoever can, please switch on the camera. Whoever can, please switch on the camera. Somebody can take a screenshot. Anybody?
Ma'am.
Okay. Okay. Taken? Yes. Thank you. Thank you.
Thank
Thank
you,
you, ma'am.
ma'am.
Thank you, sir.
Sir को thank you भी नहीं किया. He left also.
Yes, ma'am. We